In World War II, tanks were used on a scale never seen before or since in history. From the beginning, the importance of mobility, firepower, and protection was recognized, and the opposing sides worked around the clock to improve these characteristics in their tanks. Tanks became the centerpiece of many military strategies, and new and various ways were devised to protect one's own tanks and destroy enemy tanks as efficiently as possible. The initial solution was anti-tank rifles, but tanks quickly received thicker armor, making anti-tank rifles obsolete and replacing them with anti-tank cannons. This led to the parallel development of armor and the penetration capabilities of anti-tank cannons, and soon, even though effective against tanks, the cannons became cumbersome and heavy, requiring an entire team to operate and significant effort to position them where needed. This led to a different approach to combat armor, something that a single soldier or a small team could carry and use effectively to protect themselves from tanks or set up ambushes. Each country had a similar but also different approach to developing these weapons, and their effectiveness varied. Let's start with the American-made bazooka, one of the most iconic anti-tank weapons of World War II. The official name was the M1 rocket launcher, but it quickly earned the nickname bazooka due to its resemblance to a musical instrument. The bazooka was a shoulder-fired smoothbore steel tube that launched a rocket-propelled grenade. It was equipped with simple sights, and the rockets were loaded from behind, usually in bazooka teams of two, with one person firing and the other loading. The bazooka was highly effective against the early and mid-war German tanks, such as the Panzer III and Panzer IV. It could penetrate up to 4 inches of armor, which was sufficient for many German vehicles. However, against the heavier tanks, like the Tiger and Panther, it required close-range shots to hit weaker spots, like the tracks or rear. The effective range was about 150 yards, but hitting a moving target at that distance was challenging. The rocket also had a noticeable backblast, which could give away the operator's position and was dangerous in confined spaces. The early models of the bazooka had issues with reliability, particularly in wet conditions where the electrical ignition system could fail. It used a battery to electrically ignite the rocket. The operator would press a switch or button to complete an electrical circuit powered by a small battery, sending an electrical current to the rocket's igniter and initiating the launch. The next weapon inspired by the bazooka was the German-made Panzerfaust. It was designed to be a simple yet highly effective anti-tank weapon for infantry use. Its name translates to armor fist, reflecting its purpose to punch through tank armor. The Panzerfaust was a single-shot disposable weapon, making it easy and quick for soldiers to use in combat. It consisted of a small, lightweight tube with a propellant charge and a shaped charge warhead. To use the Panzerfaust, a soldier would extend a small metal sight, aim at the target, and press a trigger. This simplicity meant that even untrained soldiers could quickly learn to operate it effectively. It was particularly effective in urban combat and close-range engagements. The Panzerfaust saw extensive use on both the eastern and western fronts. It was notably effective during the Battle of Berlin, where German soldiers used it to destroy Soviet tanks in the city's streets. One interesting aspect of the Panzerfaust was its production numbers. By the end of the war, millions of Panzerfausts had been produced, making it one of the most common anti-tank weapons of World War II. It was highly effective against most Allied tanks and could penetrate up to 200 millimeters of armor, enough to disable or destroy nearly any tank of the time. However, its short range also meant that soldiers had to get dangerously close to enemy tanks to use it effectively, putting operators at significant risk from tank machine guns and supporting infantry. There were several versions, each with different warhead sizes, penetration, and range capabilities. The original model was the Panzerfaust 30, with an effective range of about 30 meters. Then there was the Panzerfaust 60, an improved version with a larger warhead and an effective range of 60 meters. The last one was the Panzerfaust 100, the most powerful version with an effective range of 100 meters and an even larger warhead. Another highly effective German anti-tank weapon, produced later in the same year, was the Panzerschreck. It was directly inspired by the American Bazooka, and its name translates to tank terror in German, in their quite creative style of naming weapons. Unlike the Panzerfaust, the Panzerschreck was designed to be a reusable, shoulder-fired rocket launcher. It consisted of a large steel tube, approximately 1.5 meters in length, with a blast shield to protect the operator from the rocket's backblast. The shaped charge was capable of penetrating up to 160 millimeters of armor, making it a formidable threat to even the most heavily armored vehicles. The firing mechanism was similar to the bazookas. Using a battery-powered electrical ignition system, the Panzerschreck's rocket had a maximum effective range of about 150 meters and typically required a two-person team to operate efficiently. Although it was more effective in penetrating armor, the Panzerschreck was heavier and bulkier than the Bazooka and Panzerfaust, making it more cumbersome to carry and operate in the field. Nevertheless, it was one of the most feared anti-tank weapons of the war. The next weapon operated on a completely different principle than any other anti-tank weapon. It was the British PIAT, short for Projector Infantry Anti-Tank. Unlike the rocket-propelled Bazooka and Panzerschreck, the PIAT used a spigot mortar system, a combination of a powerful spring and an igniting explosive charge to propel the grenade. The PIAT consisted of a metal tube with a powerful spring inside. At the front of the tube was the spigot, a rod that projected into the hollow tail of the grenade. When fired, the spigot struck a cartridge in the grenade, igniting the explosive charge and propelling it towards the target. The grenade itself was a shaped charge warhead, capable of penetrating up to 100 millimeters of armor. The PIAT was first used in combat during the Italian campaign in 1943 and quickly became a mainstay of British and Commonwealth forces, and it saw extensive action in various theaters. To operate the PIAT, the soldier first had to cock the powerful internal spring by placing the weapon on the ground, bracing it with their feet and pulling the rear handle upwards. When fired, it was designed so the recoil would recock the spring again, but that was not always the case, often leaving operators to manually recock the spring under combat conditions. The recoil was also substantial. The PIAT had an effective range of about 100 yards, though accuracy decreased at longer distances. Additionally, the spigot system did not have any backblast, making it safe to be fired from buildings and confined spaces, and avoiding creating a dust cloud that reveals the position of the shooter. The PIAT was effective against the Panzer IV and earlier models, as well as in bunker blasting roles. However, it was less effective against heavier German tanks like the Tiger and Panther. Another notable anti-tank weapon of World War II was the rifle grenade, such as the American M9. Designed to be fired from the M1 Garand, the M9 rifle grenade was a shaped charge anti-tank grenade. It had a streamlined body with stabilizing fins at the rear and a shaped charge warhead at the front. The grenade was placed on launcher attached to the rifle's muzzle and propelled by a special blank cartridge. To use the M9 rifle grenade, a soldier would attach a spigot launcher to the muzzle of their rifle. The grenade was then placed on the launcher and a blank cartridge was loaded into the rifle. Aiming was typically done using the rifle's sights or a special grenade sight that helped estimate the range. When the soldier fired the blank cartridge, the expanding gases propelled the grenade off the launcher towards the target. The effective range of the M9 was about 75 to 150 yards, depending on the angle of elevation and firing conditions. Upon impact, the shaped charge warhead could penetrate up to 2 inches, 50 millimeters, of armor. Its lightweight and simple design allowed soldiers to carry multiple grenades without being overly burdened, quickly converting a standard rifle into an anti-tank weapon. It could also be used against fortified positions, bunkers, and other obstacles. It was effective against most light and medium-armored vehicles of the time, but had trouble penetrating the armor of heavier tanks. Besides these weapons, many improvised but deadly anti-tank tools were created during World War II. If you're interested, we could make another video on that.